Alright, good evening. So today we'll continue with the next part under measures of dispersion. Okay, so we're going to look at two concepts today, something called variance and standard deviation. So in statistics, these are two of the very common quantities used to actually analyze data. Okay, now variance and standard deviation are actually measures of dispersion. Okay, it is actually used to analyze how widely a set of data is scattered, or is it narrowly scattered, widely scattered or narrowly scattered. Okay, so before we start, let's look at the definition of variance. Okay, now variance is defined as the average of squares of the difference between each data and its mean. Okay, so usually you'll actually see this is the formula for it. Okay, so symbol here stands for variance, summation. This is x, this is your individual data minus its mean. This is the mean that you're going to look for. Okay, bracket square over n stands for the number of data in your set of data given. Okay, now whereas standard deviation is the square root, okay, of the variance. So you need to look for your variance first, then you look for your standard deviation, which is actually the square of variance. Okay, now it measures the dispersion of a data set relative to its mean. Alright, so basically it's the same thing. The only difference here is, okay, it's a square root here. Okay, this is for your standard deviation. Okay, so let's look at one example of actually how we use this formula, apply this formula. Okay, so you're given, determine the mean, the variance, and the standard deviation for this given set of ungrouped data. Okay, so I've got 5, 6, 4, 9, 10, and 12. Okay, so normally we will actually start off with our mean. So mean can be written as this, okay, the symbol. So it's actually adding up all of this. So it's actually 5, 6, 9, 10, and 12 over, how many do we have? 1, 2, 3, 4, 5, 6. I've got 6. So meaning my mean will actually be 11 plus 13 plus 22. That's about 46 over 6, which gives me, okay, I'll round it off to 3 decimal places, 7.667. Okay, so that's my mean value. Okay, now I'm going to find my variance. Okay, I'm going to write down the formula first. Variance is actually the summation of individual x value minus its mean square over n. Alright? Okay, yeah? So preferably it's better to show every data substituted into the formula. So 1 over n, here n is 6. So I'm actually, okay, I'm going to open up. So we'll start with the first one. 5 minus 7.667 square plus, second one is 6 minus 7.667 square. Okay, plus, just continuing down here. Alright, next one is 4 minus 667 square plus 9 minus 7.667 square. Okay, plus I've got 10 minus 7.667 square plus 12, 667 and a square. I'm going to close. Actually, it's supposed to be, okay, horizontally written. It's just that I don't have space, so I'm actually doing this. Alright, okay, so okay, it's better that we calculate it one by one. Okay, so 5 minus 7.667. I get this, and you square it, So we'll get about, I'm going to take to 3 decimal again. 1, 1, 2. Okay, then we go for the second one. 6 minus 7.667, and we square it. So 2.779. Okay, the next one, 4 minus 7.667, a square. So we'll actually get 13.447 plus. Okay, so I'm going for this now. 9 minus 7.667, square it. 1.77. We take 3 decimals, it's 1.777. Okay, plus next one. This is 10 minus 7.667, and we square it. So we get about 5.443. Okay, and the last one, 12 minus 7.667, square it. So we get about 18.775. Okay, so we close all of this. Okay, now we add it up. This is 1 over 6. Okay, what's in the bracket? 7.112 plus 2.779 plus 13.447 plus 1.777 plus 5.443 plus 18.775. So we get about 49.5.886. Okay, just double check. 7.112, 2.779, 13.447, 1.777, 5.443, 18.775. Sorry, this is wrong. So it's actually 49.333. Okay, 49.333. Okay, so that means this one will be this one divided by 6. So you get about 8.222. Okay, so I'm taking to 3 decimal places. So this is my variance. So now if you were to calculate your standard deviation, okay, standard deviation is actually the square root of my variance. This is what was mentioned earlier. So square root of variance 8.222. So my standard deviation becomes 2.867. So these are the 3 values required: the mean, variance, and the standard deviation. Okay, so this is one whole example of how do we calculate your variance and your standard deviation. Thank you.